Okay, we're going to look at 3.5 types of polygons and polyhedron today. And our I can statements are, I can classify angles and their parts. There's a couple of other I can statements, but we'll do them when Mr. Dennis and I return. You'll also notice that we have a warm-up, but again, that'll happen when we get back. I want to talk about a little bit of geometry today. I don't even know if that was a sentence. Let's read this together. You should have this handout in front of you. While two lines may appear to be perpendicular, like look at this line or ray and this ray. They look like they may be perpendicular. However, we're not sure. While two lines may be perpendicular in a figure, you cannot assume this is true unless other information is given. In geometry, figures are used to depict a situation. They are not drawn to reflect total accuracy of the situation. There are certain relationships you can assume to be true, but others you cannot. Study the figure at the right and then compare the lists below. So this is can be assumed from this picture. And this is cannot be assumed from this picture. Take a moment, pause the video, read through these, and then we'll resume. That was your chance to pause. Moving on. Okay. Question number 1 now says, are both of these parallelograms? If so, how can you be certain? Well, if you say this is a parallelogram, it's because you're assuming that these are parallel. We don't know that for sure, so we can't say, yes, that's a parallelogram. Now, to be honest with you, this is a parallelogram. I used a Word document tool called Parallelogram Maker to make it. However, you would need these two parallel indicators, the arrows, and these two parallel indicators, the arrows, to say that this was a parallelogram. You can't assume parallel. This is not a parallelogram. I actually went in with some line segment tools and I drew this. And this line segment and that line segment are not parallel. However, those two are, so technically that would be a trapezoid. It'd be a goofy looking one. But you can't tell. You can't tell if either of those are parallelograms unless you have the parallel markers. Okay, moving down here. Can you assume that two lines that look parallel are in fact parallel? What geometric marks would need to be on this shape in order for you to know that it's a parallelogram? And this a rectangle? Well, I just answered that question. We would need parallel marks here and parallel marks here, saying that these two lines are parallel and these two lines are parallel. If you wanted to know that this was a rectangle, you would have to put right angle symbols in all of the corners, and you would also have to show that the opposite sides were the same measurement. We've talked about parallelograms using this little wood thing before, and a rectangle is a special kind of parallelogram. Okay, so what kind of geometric symbol can I use to show that this side and this side are the same length? It's called a tick mark. It looks like this. Tick, tick, and a double tick says, hey, these two are the same, and these two are the same, but these two are different. And there's some geometric notation for you. What is the most accurate name you can give each of these shapes based on their geometric indications? Okay, and I'm running across the room because I forgot to I forgot to put these symbols on my smartboard presentation. However, they were on your Word document. Okay, so what can we call each of these shapes? Well, this is a quadrilateral with one pair of sides parallel, so that is a trapezoid. This looks to be the exact same shape, but since I can't assume parallel, I just have to call that a quadrilateral. This looks like a right angle, but I'm not given the right angle symbol, so I can't call that a right triangle. I don't know. I just have to call it a triangle. Trust me, that says triangle. I also don't know if any of these sides are the same length, so I can't call it scalene or anything else. I can't call it isosceles, I don't know. So I just call it triangle. Here I have some four-sided object with all of the sides that are the same length. Well, certainly that could be a square, but it could also be this shape. That's called a rhombus. All four sides are the same length, but I don't know if there's any right angles in it. So I can only call this a rhombus. Here I've got all four sides the same length and four right angles, so that is what a square would look like. And here's something a little goofy, but it's true. I know just as much about that as I do about that. I don't know if anything's parallel, I don't know if anything's right angles, I'm just not sure. So I have to call this shape and this shape the same thing until I learn more about it. It's just a quadrilateral until I know more. Now that may be annoying because you and I both know more about it, but that's as close as we can get to naming that accurately unless we were given more information from a textbook or a quiz or a teacher or something of that nature. Okay, then we're going to talk about the homework, but I'll do that in a separate video.